So first, certain definitions such as what is gravitation is the force of attraction between any two bodies in the universe. Then what is gravity? Gravity is the force of attraction between Earth and any body on its surface or near its surface. That's gravity. What is acceleration due to gravity? Acceleration due to gravity is the acceleration experienced by a freely falling body which is getting pulled by the Earth. Okay, it's freely falling body under the gravitational pull of the Earth is called acceleration due to gravity. So you should know these terms. Okay, then what is meant by weight of the body? Weight of the body is nothing but force. It's m into g, which is nothing but the force, which is the gravitational force with which a body gets attracted towards the center of the Earth. Or correct? So everything is attraction, but different. Gravitation is attraction between two bodies in the universe. Force of attraction between any two bodies. Gravity is the force of attraction between the body on the surface of the Earth and the force of attraction between the body on the surface of the Earth or near the surface of the Earth towards the Earth. Then acceleration due to gravity is the acceleration experienced by a freely falling body due to the gravitational pull of the Earth, and weight is nothing but the force of attraction or gravitational force with which the body gets attracted towards the center of the Earth. These are the terminologies that you should be very clear with. Okay. Next, Newton's universal law of gravitation states that the force between any two bodies is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. m1, m2, m1 is one mass and m2 is another mass, and the distance between them is r. So F is proportional to m1 m2 by r square. F is equal to capital G into m1 m2 by r square, where capital G is value itself is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Newton meter square per kg square. So I am sure this also you are very clear. Okay, there is vector form, and for expressing this Newton's law in vector form of gravitation, and also principle of superposition, which I am not covering in the video. Please refer your textbook or my PDF and learn. Okay, next is shell theorem, because that's not very important, but shell theorem is very important. Understanding of the shell theorem only will help you understand this entire chapter. What is shell theorem? What is shell? Is basically a hollow sphere. That is a shell. So this is a shell of mass m, capital M, and radius capital R. Consider a point mass m, which is situated at a distance position vector of small r from the center of the spherical shell. The force experienced by this small m will be towards the center of the shell. That is, the shell will attract the point mass m towards the center of the shell, as if the entire mass of the shell is concentrated at its center. That is why it's called central force. Gravitational force is a central force. So that explains it. Suppose it is a solid sphere. It's a solid homogeneous sphere. We don't call it shell. It's a solid sphere of radius capital R. And suppose you're considering a point mass m, which is at a distance of small r from the center. It is still going to be attracted towards the center, as if the entire mass of the spherical shell is concentrated at center. That's why it's called central force. So same explanation. Okay, next, suppose take a hollow shell obviously, and take a small point mass and put it interior to the shell. The net force experience will be 0, because all the gravitational force from all the regions of the shell will cancel out. It will be in all directions and it will get cancelled out, and so the net force experienced by the point mass located inside the shell is 0. Okay, suppose in a solid homogeneous sphere, if you have a point mass m, this is at the center and r, this is small r position vector. The force with which this is going to be attracted towards the center is completely attributed by the mass of the spherical shell, which is interior to the point mass m. So then this is a small r, and so then capital M is the mass of the entire sphere, 4 by 3 pi capital R cube. M dash will be the new mass of the shell, which is interior to the point mass m, which is 4 by 3 pi small r cube. So what is M dash? Is m into small r cube by capital R cube, and cross multiplying you get m dash. And so if you're going to write the force, for this if you're going to write the force is G capital M small m by small r square. For this also it's capital G small m by small r square. For this the force experienced is 0. For this, the force experienced will be G capital M dash small m by small r square. What is m dash? You just found out what is m dash. It's m into small r cube by capital R cube into r square into m. So r square and r get cancelled. So G capital M small m by r cube into r. This is the force experienced by the point mass if it's going to be located inside the shell. These are the explanations for shell theorem. Okay, next is 1 mark question. You know that when take a hollow shell and keep it inside, point mass inside, the net force experienced by it is 0 due to the every region of the shell, correct? Because they are cancelling out. But that doesn't mean you can do shielding. Shielding means you can prevent it from getting attracted by any other body. No. There are other masses which is outside the shell which will still attract this point mass. The other masses which are located outside the shell will still attract it. And so you cannot do a permanent shielding of any point mass by placing it inside the shell. This is a 1 mark question that they will ask. After which you should know we are going to find an expression for gravity on the surface of the earth. So you know that there is two forces which are acting. One is force mg which is acting, which is gravitational force, and then you know force due to universal law of gravitation, which is G capital M small m by capital R square, because R is the radius of the earth. So you can equate both these forces. So G capital M small m by R square is equal to mg. M and m get cancelled. The small g is equal to G capital M by R square. You will see me using this formula everywhere, which is the gravity at the surface of the earth. Okay. Next term. This is only at the surface of the earth. Now we are going to explore and find what happens if it's above the earth's surface at some height. Suppose this is the earth, okay, the radius of the earth is r. Suppose we are going to locate the gravity at this point h is gh. The gravity at the surface is g. You already know the gravity at g on the surface of the earth is gm by r square. We already learned that. So therefore g at a height h will be gm by r plus h the whole square, because the total distance itself is r plus h. So therefore we are going to divide gh by g. On dividing you will get r square by r plus h the whole square. So this is a very important formula, but from this we are going to derive in different ways. So gh is by g is equal to r square by r square taken out common 1 plus h by r the whole square. R square get cancelled. From here we will go in two ways. Let's go to right. So gh by g is equal to 1 by 1 plus h by r can be written as 1 plus h by r the whole to the power minus 2, and by applying binomial theorem gh by g is equal to 1 minus 2h by r. So gh is equal to g into 1 minus 2h by r. Okay, this is the very important formula according to which, as this we have applied binomial theorem, which means it's an approximate formula which you all know. As height increases, the gravity at that point also decreases. So as you go above, as you climb up and up and up, as you go high, the gravity is going to decrease. Okay, what is the other thing that I wanted to tell you is there is always an MCQ where they'll ask you what happens to the gravity at a height h which is equal to r. This is radius of the earth. In that case you are not supposed to proceed in this direction. You can't put, you will get gh is equal to g into 1 minus 2r by r, and r get some negative answer. It's some shitty answer that you get. So therefore you stop there and go to the original formula, which is gh by g is equal to 1 by 1 plus h by r the whole square, and substitute here 1 plus r by r, because h becomes r. So it becomes 1 plus 1 the whole square, which is 1 by 4. Gh by g just is 1 by 4. So gh is g by 4. So g at a height h equal to r. It's not just when h is equal to r. Exactly. Then this is the ratio. You have to substitute in that formula. Reminder. This is a question which they've asked in entrance exams. So obviously we won't know. We'll struggle. So then that's about it. Okay, let's go to this had come even in Chettinad question paper. So that completes this. And what happens if at a depth d? Okay, consider a sphere. And at a depth d from the surface of the earth. Surface of the earth, the gravity is g. At a depth d, you're going to name the gravity as gd. From the center, the radius is r. So therefore this distance is r minus d. and as I told you, only the mass which is interior to that will contribute to any force. Okay, keep that aside. Okay, somebody has come, I don't know what to do. I'm recording. Let me stop the recording.